the next bit here, so I'm going to cover kind of what I have from my notes. So one of the things I really liked as well is that they covered in tandem basically the web UI. So here's how you do it in the web UI. Here's how you do it in the CLI. Here's some important file locations. And in case of emergency, do this or look at that. So some of that is because it's the way that Proxmox specifies it, that they need to include command line for various things. And some of it is just the way that they decided to structure it, but it flowed really well. And that's what I really like to see. I really like to see in tandem, click this and this and this, boom, this is the command that you use to get the same result, or the command that you use to verify that the action took place, etc. So I really like that. And then of course, in case of emergency, here's how to break the glass type of stuff. That is important. As far as the cluster install goes, I was really glad that they covered QDevice. I'm not sure if that's part of the required material or not, but QDevice basically, if you want to run a cluster with only 2 nodes, you can. And QDevice basically is you have a witness node, or just a node that doesn't need to be, in fact, is recommended to not be on the same network as the server nodes. In this case, we put it on the backup node that was on the same network, but they explained that typically you'd put it on a separate network just for the simplicity of the labs and stuff. The backup server was on the same network. Anyway, so we did the QDevice, and I thought it was great that they covered that, because that's something that I'd only learned about a couple weeks before the course, or maybe a week before the course. It was an offshoot of reading this book, which this book I think serves as a good introduction, and it does cover a bit in terms of firewall and other things. I'm not doing a review of the book, but the course, this is absolutely in no way, shape, or form any type of substitute for the course. The golden nuggets were not in here like they were here, but as a tangent from what I was reading here, I learned about that. Okay, so another thing is that the more nodes you have, the easier it is to manage. A larger cluster is easier to manage than a smaller cluster. Because when you have 2 nodes, you have to have a QDevice. If you have basically less than 7 nodes, you may or may not need to have a QDevice based on how many nodes you have in to be the tiebreaker vote. Let's see. Yeah, there's just more oversight that you have to have because you need to be more aware of a disk failure. A disk failure is more critical when it happens in a 2-node system. It needs to be replaced right away because you don't want to have more failures and then potentially data loss. And you can't really have Ceph won't work properly in a 3-node system, so you need at least a 4-node system for Ceph to work properly. So that's just, you definitely can have a 2-node cluster that works really well. It's just as you go from 2-node to 3-node to 4-node to 5-node, it's not as simple as if you could just start with a 5-node cluster and grow from there. Let's say that. Okay. Now, in terms of PBS, I learned so much about this because, again, this is the Proxmox backup server, and you think, oh, that's really boring. It's a backup server. They take an interesting approach that I haven't seen before. It probably exists in other backup tools, but I haven't seen it before, which is that everything is block-based, and that makes perfect sense because it's virtualization. This also means that the encryption can be transparent. So you can create an encrypted backup source, print out that JSON key, put it in the lockbox, or whatever you want to do with it. But because it's block-based, it can do the compression and the encryption and then be very efficient. You don't lose the incremental efficiency because it's based on chunks of blocks changing is how the data is written. So it's not based on a file change, it's based on blocks changing. And because of that, every backup is a full backup. Every backup is full and incremental at the same time. So it takes up the space of an incremental, but it's full. Now, the downside of that is if you're running on hard drives, when you go to restore, especially if you're going to restore more than one at a time, the drive becomes incredibly fragmented because your first backup is a full backup, and then your sequential backups are just diffs of blocks, and then blocks that are no longer used in your backup collection fall out of the way. And for that, you might need a special device, an SSD or NVMe, to host the metadata for that. so that it makes it more efficient to do the restores. Another thing that's counterintuitive is that hourly backups are more efficient than daily backups. And then what you have is essentially a daily pruning where it just goes through the catalog of all the blocks that are identified in an index file, figures out of all of the different backups which blocks are used and not used, marks all of them that are used, the ones that are left unmarked at the end are swept for deletion, and then basically put in a trash bin and deleted later. So I really enjoyed learning, in particular, how the block-based efficiency works, because if you're on a server, the Proxmox VE node, it looks like it's file-based, because you get a nice file tree. And I was worried about turning on encryption. I hadn't done that yet. I knew that I should, of course. But I hadn't done that yet because I was worried about the other things I'd have to learn, but it was all transparent. And so there was a few things there. I'm going to redo my PBS, and I'm really happy I know about that. And also remote strategies for you can have one PBS and then a second PBS. The second PBS can connect to the first and do a pull only. So the nodes can do a push, and then the second PBS can do a pull, and that gives you greater security, offsite backups, et cetera, et cetera. Another thing we talked about was core sync troubles. One big takeaway was that the latency that you need is around 5 to 7 milliseconds. It's so much more important to have a dedicated NIC or priority traffic over having bandwidth. 1 gig is all you need. I don't know if they make anything smaller than that anymore, but you probably get away with that. It just needs to be really low latency on CoroSync. And CoroSync is where a lot of the troubles come from, where if you have troubles with CoroSync, you might just be better off to do a little reinstallio if it's one node that's messed up or something, or if you're early on, if you're just doing your clustering for the first time, just reinstall. Okay. So this is a mix of the outline as well as the highlights that I got from it. And that's not all the highlights, but I'm trying to condense this down into a small video to kind of give you a flavor for the kind of things that I learned, and know that all of the individual steps of how to set everything up are in there. And then these are some of the nuggets that I pulled out. Okay. So ZFS versus Ceph, we covered that, which I think was great. We also covered versus LVM. And the takeaway was pretty much in every case, you should be using ZFS, even if it's on a single disk, which is not something that I had realized before, because my thought that was the key purpose of ZFS was part of its RAID technology. And there's some other thing I learned about ZFS in terms of its RAID technology and how that works and how to use it efficiently. But basically, you want to have high endurance drives. ZFS will write more than other file systems because it's a copy on write file system. It might be twice as many writes, but it's also efficient in terms of the way that it batches out writes and stuff. And as long as you're using it on an NVMe or an SSD, there's not too many special considerations you need other than having a high endurance drive. And outside of enterprise drives, you can look at something like the WD Red, the WD Blue. Well, there's multiple in the WD Blue series, but there's a WD Blue that's a little more high endurance. It's not high endurance like 5 drive writes per day, but it's high endurance like 0.3 or 0.5 drive writes per day. So there's that. And one of the differences between ZFS and Ceph in terms of when you want to deploy one versus the other, or perhaps both simultaneously, but using one for certain VMs or instances versus the other, is the speed versus the parallelism. Ceph doesn't get really fast in terms of single read-write performance. It gets really fast in terms of parallel performance, which makes sense because you're clustering bunches of disks. ZFS, on the other hand, locally is going to have higher speed, and you can use certain RAID methodologies, especially mixed mirroring and striping, to get particularly fast read speeds. So there are reasons why, even if you're running a Ceph cluster, you might still want to have a single disk ZFS that's replicated between another node in the cluster to service particular workloads that need that where the read and write speed, the instantaneous read and write speed, is more important for that workload than the parallel read and write speed. Another thing we talked about is in small nodes. Again, there's just a few things you got to do in small nodes. In small nodes, you can lower various full warnings like backfill full, backfill full, and I have the other one written in my notes, but that will come out. I'm working on some material, some training material myself, and that will come out in that. Another one was Proxmox versus DIY. So there's a lot of stuff you can do with ZFS. There's a lot of stuff you can do with Ceph. Proxmox has a certain setup. And if you want to use Proxmox, do it the Proxmox way. And if you want to take advantage of a few of the other benefits and you really know that you need to twist some nerd knobs or whatever, just don't do it in Proxmox. You can go through and rewrite some config files and manually edit, but then you might be coming in conflict with what the GUI is doing in some cases, or certain principles that parts of the system are expecting to exist, and you might end up making things more complicated for yourself. So if you really need the nerd knobs on Ceph, and if you need, for example, to do the object storage, rather the S3 compatible object storage, as opposed to, say, running a VM with Minio and then using the block level storage and then exposing it that way. If you wanted that directly in Ceph, or if you want to twist a bunch of the nerd knobs, if you want to do erasure encoding, some things like that, you might be better off just setting up your own Ceph cluster and tweaking all those nerd knobs there so that you have more control, more flexibility, but you're not kicking it against the pricks or causing complication for yourself using in Proxmox. That said, the defaults are the defaults for a reason. That is something that I think came through over and over again. There was a lot of explanation about various things, subtopics throughout this training, and a lot of it was kind of, here's how to have confidence that the defaults are correct. This option is historical. This option is for compatibility with this. This option is for this niche use case. So stick with the defaults and not just trust them, but being able to verify this is why the defaults work well, especially with Ceph, because it's a project that has changed substantially over the years, and the defaults that exist currently are pretty much the most performant for working with SSDs. Some other stuff we talked about, making sure that you have in your cloned, when you have templates of VMs, making sure that you have the trim guest after move or migrate, because what can happen is when a guest is moved or migrated, in some cases, especially going between different types of storage, the guest will expand from a thin image to a fat image. So you're only using 6 gigabytes, but you have 32 gigabytes allocated in the migration. That can become a full 32 gigabytes, which could become a problem for you. So because disks becoming full, reaching over 80% is one of the core problems that comes up again and again. Anyway, so having that option turned on, having the QEMU agent, running fstrim if you see something that doesn't look right in terms of disk size, will help you keep those thin. And you want to make sure that the SSD emulation and discard are turned on pretty much all the time, because of there are different trade-offs that you get on the real hardware layer when you're working with particular drives. Some of them support trim and discard better than others and whatnot. But when you are putting VMs on top of ZFS or on top of Ceph, the emulation for trim and discard is pretty much perfect. So a lot of the considerations that are hardware specific, you don't need to worry about. You want those to be pretty much always enabled, unless you know why you wouldn't. And as to the reason why they're not the defaults yet, there are a number of things that aren't the defaults yet that probably would be, except for compatibility, or because internal testing, they haven't been doing that enough to look at all the edge cases or some such. But there are a few things that are not on by default that probably should be, and the SSD emulation and discard is one of them. And I believe that IO threads is now on by default when you create a VM. Another thing about Ceph was you just want the link to be as fat as you can get it. And especially for in the training, they suggested not in the Proxmox scenario, as opposed to the standalone Ceph scenario. In the Proxmox scenario, they suggested not actually separating the internal cluster communication, the private network, from the client communication, the public network. But they were pretty clear that you want the pipe to be as fat as you can get it. Obviously, if you're using NVMEs, you need much more bandwidth than if you're using SSDs, but as much as you can get. If you can bond two 10Gs or 25Gs or 100Gs or whatever it is, gigs. I don't know, I was saying Gs because that's what I wrote there. That's why I said it. But that was something that came up, is just don't underestimate how big that pipe gets or might need to be when you've got, especially, not necessarily in the 4 node case. We get by with a single 10 gig. We don't have any problems to speak of for the use cases that we're doing. We probably bond it. I'm thinking now after the training about bonding it to be a 20 gig connection, and then also having other traffic go over there, maybe with VLAN tagging to sort out the priority or something like that. I'm not quite sure on that yet, but anyway, but if you can get more, get more. Software-defined networking was something that is not required as part of the official training. It's an optional component, but I'm so glad that Weehooey covered it. That we went over, basically, it's SDN at its core. Software-defined networking is just a category of technologies. It's not a specific technology or specification or implementation. It's just the idea that you're kind of doing infrastructure as code, basically. And you're doing it, or infrastructure as configuration. So we did not go over the VLAN aspect of it, although you can imagine the VLAN aspect of it is basically just VLAN plus self-documentation, because you get to define aliases. So instead of having to reference everywhere, okay, this was tag 20, this was tag 20, this was tag 20, this was tag 1,500, whatever, you get to reference it by its name in the drop-downs and such. That's the big advantage that you get for SDN there. There's also some advantages you get for strictly on single node that you get out of SDN using the simple arrangement, but I'm not really that big of a fan of that one. There are some security considerations there, but I think VLANing is the way to go. And then we did VXLAN BGP, and I could set that up for you now. Before, it sounded like it was more complicated than it is. It's basically install a package, set up a controller, set a few parameters in terms of the subnet, the ASN, and then you're off to the races and things just work. In both of these approaches, you still need to have a router that can route the subnets, but I thought that was done in a very excellent way to kind of show. First, he introduced the VXLAN just conceptually, and then went over to the EVPN. This was actually called, in the dropdown, it's called EVPN. The VXLAN BGP is called EVPN. So I'm going to update the name there. But anyway, that was, it would have taken me a long time. And in fact, I think that he kind of hinted at it. It took him a long time to figure it out, but once he had it and had the process, very, very simple. Also, we talked about high availability. Like, basically, you get 99.999% uptime with Proxmox if you just click a few buttons and do the standard best practices. Where that's going to vary is, obviously, your application has to be built for high availability as well. You can get a certain amount of high availability, 5 nines, pretty easily if you choose decent hardware. You don't use off-brand, unknown hardware. If you stick with enterprise grade or borderline enterprise consumer grade, something like the WD Red, stuff like that, because your disks are going to be predominantly what fails more, or somebody tripping over network cable. But aside from those, you can have really good uptime. And if you are implementing at your software layer, your load balancing, accounting for WAN failover, stuff like that, then you can get even higher. But the point is, you're basically going to get the same or better uptime than you're going to get with a lot of cloud providers using Proxmox out of the box, just with default stuff. One thing, though, that bugged me that I found out about was there is, not in the high availability options, but at the data center layer, in the system options, there is HA policy mode. And the shutdown policy should be migrate. That would do what you'd think, which is that when you need to reboot a node for maintenance, you don't have to manually say, okay, migrate everything from this node over to another node. As long as everything's in a high availability group, when you do the reboot, everything will move over. And depending on your policy, once the reboot's complete and the node's ready, things will move back live with no downtime. It'll introduce a little bit of latency during the final moments of the migration, but no downtime. Another interesting thing is you may want to test the various strategies so that you can understand them better, kind of check and uncheck the boxes on restricted, no failback, group ID, priority, things like that. You can just run the qm create command and it will create basically a virtual instance that all it does is boot up to the BIOS in a loop, but it will trigger the right statuses. So you'll have basically a no-op VM. You don't have to load an operating system on it or anything. You just create a no-op VM, doesn't have any resources attached. It'll just boot up to the BIOS and then it'll reboot. But you can use those to play around with the HA policies, which that lab that we did was really great for being able to see exactly how things work. And there was something that I learned that I didn't know, which is, I mean, it makes sense, but if something isn't in an HA policy or the HA policy is restricted, then when you go to shut down a node, the node will not shut down. It will stay in a pending state if the shutdown policy is migrate. If it, for whatever reason, can't migrate one of the instances off to something else. So it's just something to be aware of. We already talked about Ceph hyperconverged. You need to have 4 or more nodes, because you have 3 nodes and you lose 1 node, you immediately go into read-only degradation mode, which is no bueno. Whereas if you have 4 nodes, you can lose a node, and as long as it's not within the same second, you can also lose any particular drive in another node and still have everything operating just fine. With ZFS replication, that's ideal for 2 or 3 nodes. You are taking up the full amount of space, but it does a block level replication, and you can do it every minute. So this essentially gives you almost the same benefit of Ceph, where Ceph is to the block right accurate. ZFS replication, you can be to the minute accurate. So if there was a catastrophic failure, you lost a disk, a node had to start on another instance, it would only lose a minute's worth of data at most. Then we talked about API. What was interesting here was I have not been following the principle of least permission, not because I didn't want to, but because I didn't know where the permissions were outlined. And for what I'm doing right now, where we're not yet exposing any of our tokens to customers or building something that funnels customer access through a particular token, it hasn't been a top priority. But what I found is, and was shown, was that on the API documentation at the very, very, very bottom for each individual API, there's a section that outlines the permissions. And so now I'm going to redo the token that I've been using to follow that more strict set of permissions. That's actually something that I'm excited about, because as we do have 3 people that are administering over our cluster, myself, Ryan, and Jojo, I want to make sure that when we're using our tokens for setting up things for ourselves or our customers, that we're using a token that's limited in scope so that we're not accidentally making mistakes as we develop our own scripts, that especially ones that would affect someone else's instances. And then we talked about PVSH. So there's a command line tool that interacts with the API. And I like the way that it was presented as basically an on-ramp from ClickOps to DevOps. So if you're not ready to script everything and figure out what the APIs are and integrate that in Go or Python or whatever it may be, look at what you're doing, open up the web inspector, see what calls are happening, and then you can take that and run the same thing with the PVSH command. And then you can start to build up scripts that are just based on this, and that gets you from doing things manually to having a self-documented script that is doing those things. So I thought that that was really good to learn about. And then we talked about the Proxmox Data Center Manager. This is a new thing that's coming out. We did a demo of it, and it basically just gives you multiple data centers at a glance. So a data center being a cluster. It gives you, I guess the term that they use is actually not data centers or clusters, it's remotes. It allows you to manage clusters or individual one-off servers in a mix of remotes and you can see the health of, I guess, your whole data center at a glance, rather than just thinking about it as, let me go log into this cluster, let me go log into this cluster. If you have got multiple clusters, or you've got some nodes that are not part of a cluster that are doing some specialized task or have some specialized purpose, you can add all of them to the Proxmox Data Manager and get it at a glance. And you can do live migrations across clusters. This is only CLI for now, but it is going to make it into the UI. It's on the roadmap. And yeah, so that is kind of a brief of the kinds of things that I learned. Again, this is not a layout of how each section went and exactly what steps we did, what labs we did, all that. But I would recommend, for at least for Americans, Canadians, North Americans, people who have a culture similar to America or Canada, you probably want to go with the Weehooey training, not only because it sounds like they are far more rigorous than what is required, but also the culture match. They talked about some different experiences with different companies from different areas of the globe that they worked with. And it sounds like a culture fit is important for the training, because there's certain expectations in certain cultures, especially in terms of leadership, who's allowed to speak, who's allowed to ask questions, or protocol, things like that. We Americans are very boisterous and loud oftentimes, at least I am. I'm not typical of all Americans, but I think that I'm probably better suited for the environment of Weehooey than I am for the Austrian, because of culture differences. My American culture more closely aligns with Canadian culture in terms of how we ask questions and demonstrate respect and inquiry and things like that. So I think that both technically, from things that they said, and they weren't putting anyone down, to be clear. They're not saying, oh, well, it's good you got the training from us, but there was just things that they said about the other training. It's just, I gleaned, oh, they're really putting the extra foot forward on this, and they're really not punching above their weight per se, because they are punching at their weight, but above the requirements in terms of the smoothness of the setup, that a lot of the other classes are not. The structure is different, and at least for me, this structure I know works better. I hope that gives you an idea of what kind of value. Well, first of all, I hope that this video provides value to you. Like, thumbs up, follow, sub if you want to, if it does. But I hope that you have a more clear understanding of what kind of value that you would get out of the training, what kind of topics it covers, what it's like. Now, again, I did the clustering training. I want to go back and do the administration, the virtualization and administration training. I know that there's some gold nuggets there that I am really looking forward to, but this is what I got for now. So I hope that in of itself provides some value to you. That's my spiel. That's what I had to say about my experience. Let me know if you're thinking about taking the Proxmox training. Is that something that's been on your radar? That all said, adios.